Let's look at today some things that we have done in other languages like C++, object-oriented concepts, and let's see how what is Rust's take is on those things. So, for example, we look at things like how does Rust basically implement O, and we look at some concrete examples. I don't want to just go over a bunch of talk. So, what we'll do is we'll today focus on some of the things, some concepts like struct, impl, and traits. So, what is that? What are those things? So, you would see that that these are similar to the C++'s object-oriented concept, but they are slightly implemented in a different way. So, for example, what Rust does is it basically doesn't group the data and behavior under the same umbrella. So that umbrella in C++ was class. As you know, that we used to have data and methods. But in Rust, it kind of separates out this data and behavior. So data is separate, behavior is separate, and for that they have these keywords like struct. Struct is for data, and the behavior is implemented with impl keyword, and the rest is you guys already know, like what is the idea behind it. I'm pretty sure you can. We don't have to be told like that a struct has some kind of related data, whereas the impl block defines behavior of that data. So let's look at very typical examples rather than going with. So we have this file impl.rs. So let's see what it's doing. So this is struct example. It has only one variable number, and it's not even assigned at this point. It just says it's supposed to be bound to a variable, but the type is given. The type of this particular field inside the example is I32, and as you know, we are defining a struct, so it's not like we have to initialize the number at that point. Now, in any case, so the here you see the first example of impl block, and the impl block is there with the same name as the struct. So that's important point, obviously, because otherwise it wouldn't be able to group the associate behavior with that data. So impl block basically defines as behavior for a struct example. So now we have to understand two concepts. One is associated function, and other is the method. So when you see method, you would see things like it has things like self as the first parameter, whereas a associated function, in this case this foo and boo, they don't have any arguments, and they are basically a kind of it is looking to me that they're more like static functions in C++, which are inside a class. So they're more like for the whole class rather than just one instance of the class. So here you have add42 function, which basically takes a mutable reference and modifies the number. As you can see, it adds 40 to it and it prints. Then we have a get number method, which basically returns the number. Now then we have trait. The first time we are coming to these this new syntax, this new keyword trait. So we have already seen three new keywords today. One is struct, and then we had impl implemented for the implementation block, and then we have trait. And trait is sort of like an interface. So you can define a trait at this point. When you say there's a trait thingy or whatever you hear it's given, it could be for anything. It could be, doesn't have to be for the example in this case, or it just, and you say there's an interface it provides is do thingy, right? Now then you can implement that. You have to implement that trait for that particular. So you have a impl block, but this time instead of just saying impl in the struct name, you say impl interface name for struct. So you are implementing interface for that particular piece of data. I mean, for this type that you define, which is example in this case, and then you can simply just, in this case, we just print it. As you can see, it's also a method because it takes the instance of that particular. And then we define another trait, a square. Obviously, you should be able to square a number, right? A number should be squareable unless it is a complex number. If it's a regular number, it should be squareable. So now here you see we have a new trait, a square, and we are saying this will provide interface SQR, being able to square the number. So now here we are implementing a square interface for example struct, and all it does is basically raise it to the power of 2. And then now this is the main function where we have immutable reference. X is a number, example is a name of the struct, and the variable name, one of the data inside what we used to call in C++ as member data, is inside that is number, and we initialize that to 3. Then we call these associated functions. You can see for that we don't need to have instance. We just simply called it like this kind of syntax, boo and foo. And then we said call add 42, but for that we actually used x dot add 42. And because add 42 takes immutable reference already, that's fine. And then we print the number again by calling the get number, which is also a method. So add 42 and get number, both are methods. Then we called x.sqr, which was an interface that we had implemented on this for this particular piece of data. So that's your first OO, trivial OO program, and that you can try on your system. So let's try to compile it. We'll say rush c impl.rs, and let's see what happens. And so we have the method, the associated function boo that was called was just it have just a printf and the println, and then we had the number is 45. I think, let's see why. Okay, so number is 45. Example boo example for x dot add 42. I think it added 42, and instead of saying 3's number is 45, so that's coming from at 42. The number is 45 here. And then we say square, then we call x square and square, and then we got again. So here we go. And now just to consolidate, let's before we move on, let's look at one more example. And this example, let's see, we have one more. Okay, so here what do we have? We have Rust style O. What is the Rust style O? You define a piece of bunch of data. You group a bunch of data inside this your user defined type employee. And you say employee will have an ID, and ID will be of type U32, and then will be a name. Obviously, it will be of type string. And what I like at this point is I'm using the word string, but I don't have any include IO string or things like that, which is a very neat thing. Now you see you're having implementation block with the same name as that of the struct. So impl employee. And so we have two methods, each of them takes self, as you can see. And they basically print the ID. The first one is show detail, it prints the ID. Other is change name, which basically takes immutable reference, as you can see. By the way, ampersand, this symbol means reference. It is only borrowing, so it's not really you can you can go ahead and start freeing the piece of the stuff that is associated with a reference. It's just a reference. So you got to understand the concept of borrowing in Rust. What is borrowing? You're basically borrowing a reference. So here, anyway, this change name actually modifies because it was a mutable reference. And then we have associated functions. You see, this was not taking any self or anything. So it can, in this case, you can still call on it. You can still call like, let me see. So we have create employee. Let's see when we call create employee. Yes, you see with those double quotes, typical class. So with a struct in this case, a class name or struct name, colon colon, and then we call create employee. And I think this is how Rust provides some C++ functionality. Like for example, if you need a constructor, you might be wondering what happened to constructors and destructors in a struct employee. So that can be implemented using these things like these associated functions. As you can see, they are called on the class and they create an instance of that class and then basically return the instance. And you might be wondering where are they returning. So the last function, if you don't have an explicit return statement, that becomes the return value. It's like Ruby or something I heard. So here is create employee, and same way you could think you could implement like new. If you had a string object class or struct, you wanted to have implement new, you wanted to create a new string, you can simply, instead of create employee, you could have a new. And I think this is what we had. If you search in our code, you would see, I think there was a new somewhere, if I remember correctly. So there we go. So we have here, for example, here in this example, you see let mode gas equal to string dot new. So basically this is also, here you can see it's calling is with this double colon. You can see they're calling actually associated function new of the string type. Okay, so you understood today. Actually we didn't run that example, so let's run it before we say goodbye for today. And then we say impl3.rs, and let's say, of course it will work, no big deal. Employee ID is 1, and you were able to change the name because you passed the second method a mutable reference, so you were able to change the value. And you could say, and then the employee name is Rusted Lover. So if you see the code again, in the main function, what do you see? You see we created a instance immutable. As you can see, this is very important to always understand that let creates a immutable reference. So sorry, instance in this case. So as you can see, this immutability that we used to call in our first lecture, out of using some crude terms, we used to call that Rust. In Rust, everything is constant, but actually everything is immutable by default, and the real constants would be immutable forever. So that's that key difference, that subtle difference you got to know. So here we created immutable instance of an employee, and then we said, hey, show details. Then here we actually, the previous instance was shadowed by having this creating a mutable instance. This is whenever you say let, you're not just assigning, you're actually creating a new piece of memory or whatever, and then assigning the same variable name to that. So e dot change name, we changed from Harper data. Then we actually call just to verify that it really changed. We got it here. Now you say, I'll tell you one thing, something, let's try something for fun. If you remove this mutable from change name, if you remove the mutability of the self, it will give you a compiler error. I'm pretty sure about it. So now you do that here. Let's see that. Now let's try to build it again. Here you see, cannot be written. He is saying it's a immutable reference, so the data it refers to cannot be written. And he is in fact telling you, even consider changing this to a mutable reference. So Rust compiler is very, very useful. and I am very impressed by that actually, considering coming from C and C++ background. That they give you so much data, so much information. So now you see, we change it to mutable, and we are able to. Oh, we said aborting due to 4 previous error. What happened? Um, Help remove the mut prefix. Okay, he's saying that he doesn't like the. He's saying remove the mut prefix. So here, I think you have to have um, this after reference, not I think before. This should take care of it most likely. I'm assuming. Okay, let's see that this time. And there you go. So that basically. So now you understood some new concept today, and I hope it was a useful class, useful discussion. I don't like to call it class. We are discussing things. So feel free to subscribe, refer to your friends if you want to support the channel, and I'll see you guys in the next class, next discussion again. Sorry, and take care. Bye.